All right, looks like people joining have slowed down, so we'll crack into it. Welcome everyone to the second of our lunchtime seminar series. I'm Carl Wilton, I'm the chair of the cadastral stream. And today we're looking to cover off, to provide some CPD to help cover the land development engineering competencies that cadastral surveyors need for their licensing. Just a couple of housekeeping matters. Can you please make sure your cameras are off if you're not presenting, and please ensure that your microphones are muted. Any questions, can you put them in the chat, and we'll look to try and answer those at the end of the presentation. And welcome to Sam Godwin. He's presenting for us today. Sam is a chartered professional engineer and director at Cuttress Consultants in Lower Hutt. And Sam was born and raised in Gisborne before heading to boarding school in Hawke's Bay. Drawn to maths and problem solving, he moved south in 2013 to study civil engineering at the University of Canterbury. After graduating, Sam began his career with a small land development consultancy in Christchurch before relocating to Wellington in 2019 to join Cuttress Consultants, following his now wife, North. He became a chartered professional engineer in 2021 at age 26 and was appointed a director of Cuttress in 2023 at 28 years old. Sam's current focus is on people leadership, client relationships, and supporting regular developers with site selection and early stage site design. He has a particular interest in multi-unit developments and the unique challenges that they present, both technically and in navigating the regulatory environment. Outside of work, Sam's currently training for a Hyrox race and preparing to become a first-time dad in August. So there's plenty keeping him on his toes this year. I just looked up what's involved in a Hyrox race, and I reckon becoming a dad is going to be easier. Although the recovery time might be a bit longer. But anyway, over to you, Sam. Thanks very much for joining us.
Yeah, no worries, Carl. Yeah, that's always the first question. What the hell's Hyrox? I've only done one before and it just about killed me, so I don't know why I'm doing a second, but anyway, there we go. Thanks for the introduction. Yeah, so I think we've got a few of our Cuttress team tuning in, sitting in the same office. I'm just sitting separately to them, but booked out the meeting room to listen in. It looks like there's quite a few on today, so yeah, hope you guys get something of value out of this. I guess, yeah, multi-unit developments, my particular interest in that. I guess that kind of comes from when I was down in Christchurch working after university. We did quite a lot of greenfield development down there, which was only 2 years of my career. But since moving up to the Wellington region and Cuttress Consultants, I've been based in the Lower Hutt office, and a lot of the work that we are doing is the multi-unit development, and a lot of that is stemmed from just the availability of land, I guess. Lots of hills around here, not so much flat land, or the flat land that is available is already taken up by housing. A little bit different for our Kapiti Coast office up in Paraparaumu, where there's land available, so there's a bit more greenfield development, I guess, happening out of there. But yeah, it's certainly been a large part of my work over the past 6 years being at Cuttress. I've actually got a slideshow. Always find it's easy to have things visually. So I'll just bring that up now. Yeah, so, and just a little bit more on the multi-unit side of things, I guess. It's interesting seeing a little bit of a change in the market at the moment. We're seeing developers who have been doing a lot of the multi-units around Wellington starting to explore different products, and those seem to be, the flavour of the month anyway, seems to be these standalone dwellings. They've got a zero boundary, I'll call it, on one side. Surveyors will correct me there probably, but and then you have a 1 metre boundary for the next dwelling over, And what that creates is you're still kind of getting that density you get from the multi-unit developments. But it's, I guess, perceived by the market as a slightly different product. Haven't been involved in one yet, but there's certainly lots of discussions happening. And I guess a general shift away from trying to have resident associations as well. But I think really what that all stems down to is that buyers have choice at the moment. So right across the country, there are a lot of multi-unit developments that have been constructed and sitting on the market. So buyers have choice, and they can choose, you know, a standalone product now might be preferable over, you know, multi-unit freehold titles with party walls. So the topics I was going to touch on today was just around, I guess, engineering design considerations. And these are the things that, you know, I and we focus on here at Cuttress, and that might differ between wherever you're working, up in Auckland, if you're down south. But these, I guess, are the main ones that we have to focus on. So we've got stormwater attenuation or detention, stormwater retention, which is a newer thing here in Wellington. We've just been required to think about over the last couple of years. Wastewater mitigation, how flooding, you need to consider flooding in development design, a little bit of geotech and what impact that has on our foundations. We don't have geotech in-house, but we still have to work closely with external geotechs to understand how that impacts our developments. A little bit on roading, and then I guess a large part of what I'm doing at the moment is helping clients select sites. So I guess I'll just touch on at the end a little bit of, you know, I guess due diligence, that advice that we provide to help our clients out. So first up, just with stormwater, I guess high level, some things you're considering when you're thinking about stormwater design for development. Are you making any changes to primary flow? So, you know, is that culvert installation, or do you have to move pipes, realign pipes around your development in order to get a house on that and not build over it? Changes to overland flow. So is your, you know, maybe a development sitting at the toe of a hill, how are you accounting for overland flow that might be coming from a catchment above, so you're not changing that or causing, I guess, not nuisance to neighbouring developments or neighbouring sites. Loss of ponding. So are there low points across the site? Are you proposing to fill them? If you're proposing to fill them, what impact might that have on displacing that flood water that's there in large storm events? And last one, just around impervious surfaces. So what was, you know, maybe if you're talking about a greenfield development, but you're then introducing a whole lot of hard stand, you're likely going to be increasing the runoff flow rate and the volume of water coming off that site. So is that going to impact the likelihood of flooding, or how are you going to, I guess, mitigate those effects? So I guess one of those things around the impervious surfaces, an introduction of that is stormwater neutrality. This has been something that I've had to consider since I've moved up to Wellington and Cuttress, so for at least the past 6 years. And I guess the concept is that you are detaining stormwater flows, the increase in flows on site, and it is released or controlled by a small orifice to be able to control that flow rate. And what you're ultimately trying to achieve is the runoff post-development. So after your development's built, needs to be the same or less than the flow rate that was leaving that site pre-development. So Wellington Water some time ago released a whole lot of acceptable solutions, and it's something they keep adding to. But what this document provides, which is just the snip here, this is one of their acceptable solutions, is basically a toolkit for anyone, say architects, that could pick this up without having to do the complex calculations, I guess, and get into the weeds of that. They can adopt these if they meet a certain criteria, of which there's about 8 or so. So they might look at their site, they're putting a 80 square meter house on it, and therefore they can choose a 2,000 litre tank, and then in subsequent pages it talks about the orifice size and orifice height on the tank and things. Some of the other solutions they have, they've released below ground tanks, and some of the in-slab aquacomb pod tanks, just to allow, I guess, some variety for different solutions. We at Cuttress here use a program called HEC HMS, and that allows us to do or design bespoke, I guess, solutions, which is good for larger developments where they may not meet the criteria of these acceptable solutions. The beauty of the stormwater neutrality concept, because you're comparing it to pre-development runoff rate, if you say are developing what was a fully impermeable site like a car park and putting housing on it, you're unlikely to be increasing the stormwater runoff post-development. So this consideration then doesn't result in the use of stormwater tanks and restricted orifice and the likes. So about 2 years ago, Greater Wellington Regional Council introduced notified their Plan Change 1 to the Natural Resources Plan. And in that, it introduced the need for stormwater retention, and they did that through terminology called, which is hydrological control. So different from neutrality that we were just talking about. But what this concept focuses on is really the erosion of freshwater streams and the impact of development on the ecology within these freshwater streams. And it also introduced some lower thresholds to require stormwater treatment as well. But I'll just focus on the hydrological control aspect. So unlike stormwater neutrality, which focuses on our previous slide, looking at the 10% and 1% AEP events, so that's your 1 in 10 and 1 in 100 year storm events, so quite large events. This really focuses on the smaller and more frequent events, so talking about kind of a 2-year, 24-hour event. And I guess it's looking at trying to reduce scour in the streams, and I guess some of the, say, fish that are in these freshwater streams that may be used to having to navigate little bursts of water during a storm event, but due to the increasing development that we're seeing, they may need to navigate what was a quick burst of water for a longer period of time, because we're now, with our neutrality concept, holding water back and releasing it for a long period of time. Unlike stormwater neutrality as well, you don't get to look at the pre-development state and offset from existing impervious areas. You have to consider the pre-development site as a greenfield site, and it has very low triggers in order to require the need for retention. And that is around about 30 square meters. So it can catch up, well, I guess catches things such as, if your architect's doing just a single house design, you don't need to subdivide in order to trigger the need to consider stormwater retention. But I guess just to talk through some of the some of the solutions that we have come up with over the last few years. For dwellings, to reuse stormwater, you can, I guess, adapt the above ground tank that we see as a common solution for stormwater neutrality, that you can see here on this right image. But instead of having, say, an orifice at the bottom of your tank and your full tank as just storage for the purpose of neutrality, you raise the orifice up a bit higher. Therefore, you've got kind of this dead storage, which then can be used as reuse within your dwellings. And what that looks like is plumbing that back into fixtures, non-potable fixtures such as toilets and washing machines. So this is becoming more common, I guess, around particularly the Hutt Valley, where a lot of our public stormwater network discharges to streams that run down the valley. In Wellington City, we have some of your public network, or Petone around here, where the public network discharges directly to the ocean. Then you don't need to consider, I guess, this retention and reuse requirement. For, say, a multi-unit development such as this, where you may have a large right-of-way, you also need to consider how you are going to reuse water from that. And we've worked closely with some of our regular developers, solicitors around, I guess, the complications of catching water from a common area and plumbing that back into units. So we, I guess, in that explored a range of solutions in order to try, I guess, reuse that water. And the most straightforward one being that you test for soakage in the area, of which it's not awfully common throughout Lower Hutt. There's a lot in Upper Hutt around here, so it's an easy solution there. But you're putting the design storm, so the small storm event, into soakage when kind of having groundwater recharge. If you don't have soakage available, then basically it can trip you from being a permitted activity to something where you can't meet, I guess, those requirements, and therefore you have to apply to Greater Wellington Regional Council for a stormwater consent. So that's all on stormwater. One of the other considerations that's come up, that actually wasn't here when I got to Cuttress in Wellington in 2019, is this concept of wastewater mitigation. So I guess your traditional wastewater network, you can have a gravity lateral coming out of your dwelling, likely connect to a gravity main in the road, and that, depending on topography, might go through a pump station before making its way down to the treatment plant before it's treated and sent out to sea. I guess over the last, well, we hear a lot in the media, and there's been a lot of movement around underinvestment in our infrastructure, and the likes of, well, for wastewater, leaking pipes may result in a whole lot of stormwater getting in there. You may have cross connections, groundwater infiltration. We see a lot of tree roots making their way into sewer pipes, which reduces its capacity. And all these things result in, these pipes being at their full capacity, not necessarily just due to wastewater, but all these other problems if they are aged pipes. And we see a lot of the stuff around the Hutt here was installed around 1950s and hasn't been renewed. So there's a lot of old infrastructure. On top of that, you have urbanisation. So talking about multi-unit developments, what was previously a single house then gets demolished, and we're putting typically around 8 to 10 dwellings where that one house was. So yeah, the net result is a lot more wastewater going into the council network. When I got here in 2019, they were starting to talk about some of the network. I think they're doing, Wellington Water was doing a lot of modelling around their infrastructure capacity. And they were realizing at that point that didn't have capacity for new development. And I remember my first development here, we had to install some oversized wastewater pipes, which were within our development, but connected up to the council network. And what that allowed was basically a backflow from the council network when it was at or exceeding capacity to backflow into these large oversized pipes in our development. It's progressed from that point, and they introduced this wastewater mitigation concept or requirement. And what that requires you to do is store the wastewater within your development and discharge it at off-peak times. So the times we've got on screen there are our peak times. So you can see it's early in the morning and in the evening. So that's when everyone's at home and showering, dishwashers and the likes. I guess, yeah, having that peak discharge of wastewater and sewer from housing. So some of the solutions that we've been working with over the last few years is these tanks like this. So using a low pressure sewer network to store the wastewater and then discharge it at those off-peak times. So for individual dwellings, like the picture on the right there, you might have a single little pump station, which will have your gravity lateral connection from your house. Wastewater will store up in there at those peak times, so it won't be allowed to discharge. And then once it reaches the off-peak times, the pump can kick in and then discharge the wastewater into the council network. For multi-unit developments, we've been using these shed tanks. Polyethylene, EcoFlow is probably our main supplier of these tanks. And there's other companies like Aquatech and the likes that also work in this space. But where you say have a multi-unit development and a shared right-of-way or a green space where you a larger space where you can fit one of these larger tanks, all of the houses within that development will need to they'll discharge to this tank via gravity network. You can see its size to be a lot larger, so it can hold a lot more wastewater. And then the same concept where you get to those off-peak times, the pumps can kick in and start discharging it out into the sewer network. I guess some of the challenges we have with these systems, where you have an individual tank for an individual house, when there's blockages, it's clear where the problem has come from. But when you have these multi-unit developments with shared tanks all discharging via gravity network, if there are wet wipes or other products that are going down into the wastewater system, they can block these pumps, and then it becomes everyone's problem, I guess. You'll have alarms going off, the wastewater will be building up, and no doubt there'll be a cost for a contractor to come in and service or unblock the pumps, which results in, if there's a residents association or something similar, body corp, that's a cost that everyone has to bear due to one person's, I guess, maybe lack of understanding of what can and can't go down the sewer system. And I guess the other thing is that it often requires, residents associations to be in place to properly manage these systems as well. So there's some sort of structure and funds going into a shared bank account, so these costs can be managed. So that's wastewater mitigation. So flooding. I've kind of classed this into three types of flooding that needs to be considered, or scenarios that need to be considered. So we've got no known flooding, and Wellington Water has done a lot of work over the last 6 years around trying to map the wider Wellington region so we can understand where sites or areas inundated or subject to overland flow in that 1% storm event. So if you're lucky enough to have a site that doesn't have any flooding or isn't subject to any flooding, you can set your floor levels in accordance with New Zealand Building Code, and that might be 150 mil above the crown of the road as a minimum, or if your site's falling away from the road, you might be 150 above the rear of your property. Another, I guess, a first type of flooding is inundation. So that might be a low area where you've got ponding, not necessarily having flooding that has a high or any velocity, I guess. And then you have overland flow. So that might be where you've got, some level change throughout your site or in the road, and you then have a concentration of flood waters, which has a velocity, which is often harder to manage. So I guess some of the design solutions that or pathways we have to navigate this, where there is flooding, inundation or overland flow, is path of least resistance is generally to pile all your dwellings and not change the existing ground levels. So that's kind of our picture on the left there. So you'll be provided a flood level from the modelling, and then you have to apply a freeboard to get to the underside of your joist structure for your house. I guess some other considerations we have to think about when we do that is there's New Zealand Building Code requirements for crawl space. So if you have, say, 100 mil of flooding on your site, you need a 200 freeboard, so you're about 300 mil to the underside of your joist to dictate your floor level. Building code requires a 450 mil crawl space from the underside of your joist. So I guess when you go to piling as a solution, it suddenly means that you're, to the underside of your joist, you're already 450 mil in the air, and then you might have 150 mil joist and flooring thickness. So 600 mil, and then suddenly you're 3-4 steps out of the ground to get up into your house. And actually, we've had some comments in the last month or two from some of our regular developers that, again, back to my comment at the start around buyers have choice, they're finding that these sites with piled solutions are struggling to sell when a buyer can walk down the road and get something that's slab on ground. So other solutions to navigate flooding, you could look at filling the site completely and trying to achieve slab on ground. But in doing that, you need to consider whether that will have an impact for your neighbouring sites. Wellington Water talks about a maximum limit of 50 mil as having a less than minor effect on neighbours. So if you're in an inundation area, you might be able to figure out the volume of water displaced and see what sort of impact that has across the floodplain area. But it gets tricky when you start getting into that overland flow path area, because it's hard to determine, how that water will react as a part, if you're looking at filling the site and say blocking a flow path. So that's where flood modelling comes into it, and that's not something we have internal expertise for. So we work with other consultants if the developer wants to, I guess, navigate or explore trying to fill the site and ensuring that it doesn't have an impact on neighbouring developments. So this is just an image of what we typically see or receive from Wellington Water. Some of the mapping in our area is publicly available, which is handy when you're trying to have a look at a site and provide some quick advice. And the likes of Lower Hutt, it's available online in a GIS, but they've just recently released some in the Upper Hutt area catchment, and that's not publicly available at the moment. So this is something that we requested comments on recently in Upper Hutt. And you can see they provide you with a maximum depth of flooding, minimum depth, speed of flooding, what datum you're working in, and then minimum floor levels and flood levels, I guess. So if you're looking at, say, piling the site, you know what sort of level you have to get up to in order to be, I guess, designing to that 1% AEP flood event. Just to quickly touch on, I guess, geotech again. So as I said, we don't have in-house geotechs, but it's something we need to consider as we're designing these developments, the landform, understanding earthworks volumes, what you need to dispose of off-site or bring into site. So there's a New Zealand document, NZS 3604, which talks about defining good ground. So that's, they define that soil strength, that anything with a bearing strength or capacity of 300 kPa is considered good ground. And what that would allow you to do is put a standard 3604 slab on the ground. If you can't meet that requirement, you may need to get into doing some ground improvement. And the two main solutions, I guess, that geotechs use in our area is gravel rafts and piling. So if you've got poor material near the surface, but you've got some good material or soils down low, gravels or rock, you may be able to pile down and have end-bearing piles. Otherwise, in the likes of Wainui-a-Mata, for those that are familiar with the Wellington region, it's very poor ground over there, and tend to use, I've got gravel rafts up there, but gravel rafts, which is undercutting, say, around 600 millimeters, removing that material off site, and then laying geogrid, which is a product to enhance the strength of the soil, and backfill that in layers with a product or like a aggregate such as AP65. In around 2021, there was a big change in the geotechnical standards and the peak ground acceleration, which they had to consider. So they had to consider a far larger earthquake event, I guess, than they previously had. And that ended up having quite a big implication on how we do navigate these solutions, because what before the introduction of those new standards might have been a undercut 600 gravel raft that I was speaking of might now look like 1.2 meters of undercut with all the geogrid. And in the Wellington region, we really have a shortage of landfills to dispose of that poor material to cut off site. So it's really expensive. So it had a big implication on the cost and, I guess, feasibility of sites. So developers, I guess, tried to explore or avoid, I guess, Wainui-a-Mata, made it harder to make the numbers stack up over there. After that introduction, we saw a lot of, I guess, that Canterbury technical guidance that was produced after the Canterbury earthquakes being used up here. And what they do is they define it into technical categories 1, 2, and 3. 1 being good ground, 2 a poorer soil structure, and 3 is very poor soil. And we see solutions in the TC3 land with such as the 1.2 meter gravel undercuts. some, I guess, difficult solutions we've had to navigate, or problems we've had to navigate, is where you have a poor soil condition, but you also have flooding. And we've seen some very expensive solutions drummed up out of that. One of them being where the developer was required to undercut, build back up a gravel raft. And then because piling wasn't possible because the ground was so poor and there was no better material down low, you had to build up the gravel raft, construct a concrete strip footing in that gravel raft, and then have piles coming out of it to get your kind of timber subfloor and allow for that flow path to continue through the site. So essentially the developer ends up paying twice for a foundation solution, so it does get quite costly. Roading, I guess some of the main design standards that we're using here is NZS 4404, which a lot of you will be familiar with. And another one I commonly have open is 2890, which is the off-street car parking design guide. At Cuttress, we work across quite a lot of different councils, and some of the ones I'm regularly working across is Wellington City Council, Hutt City Council, and Upper Hutt City Council, all of which have different ways of doing things. Some, such as Wellington City and Upper Hutt, have their own code of practice, which you need to consider. Hutt City Council points to 4404, but there's been all the councils have reviewed their district plans, and what we're seeing is a lot of them are being more prescriptive, I guess, within the district plan about their own requirements when it comes to roading or off-street car parking. And they're also seeming to be, I guess, over and above the requirements of what we see in 2890 and 4404. And lastly, yeah, just a bit on the due diligence advice. So we do this with some of the developers we regularly work with, or like any of us, if you have a new client, you want to make sure that they're informed before they're proceeding with spending a significant amount of money with any development. So when I was talking about the geotech solutions and I guess needing to pay twice for a geotech or foundation solution, you want to make sure that your client's informed before they get into it and know what they're getting into. So making sure the feasibility stacks up, I guess. So some of the key things we look at when we're just having a high level quick look at a site will be, if we need to, seek some comments from Wellington Water, and that will be on things like the capacity of the three waters infrastructure. We know stormwater neutrality, the concept we talked about at the start, is required as a standard, but you're testing to see whether wastewater mitigation may be required and whether that needs to be factored into the feasibility of the development, and checking to see whether there's enough pressure and flow in order to adequately supply the site with water, and other things like hydrant locations to make sure that that conforms with the relevant standards. Also, what we get from Wellington Water, as you saw earlier, was a flood map and understanding, if the site's subject to flooding. So that's known up front. Another thing's comments from Wellington Electricity. We are finding more and more that when we go to do these infill, brownfield, multi-unit developments, that there's needing to be infrastructure upgrades to the power network as well. So I guess same with wastewater, the demand on the infrastructures going over and above what was probably anticipated when those networks were put in. So if you need to suddenly install a new transformer or something like that. When you're going to put, do your development, that's quite a significant cost and something that's worth knowing up front. And then we'll check other things like other site restrictions, such as the zoning of the land, any restrictions on the title, and any street features that may impact the development. And I've put this photo up here of a street tree because this became a massive problem on one of our sites. Because while they are beautiful, you might get a poda car with roots going everywhere, and council put a lot of protection, I guess, around these street trees. Often don't like them removed, but also you have to navigate those roots and have arborists involved in order to put your civil infrastructure in. And when you're doing these multi-unit developments, there's a lot, you're generally connecting out into the street, council mains in the street, so you have to navigate that root structure when you're laying your pipes, which again can become costly. So I think that is the end of my presentation. Back over to you, Carl, or happy to take any questions on the presentation.
Yeah, thanks very much, Sam. That was an awesome presentation. I learned quite a few things there. Things have changed a bit since I was last in private practice, that's for sure, in terms of stormwater retention and that sort of thing. We do have a question in the chat from Richard Hemi. Hi, Sam, great presentation, thanks. With regard to wastewater holding tanks, do you think some enhancement or additional requirements could these act partly as septic tanks and pre-treat wastewater, maybe ultimately reducing pressure on the public system further?
Yeah, so we're exploring something a bit different as well, and I'll go on a bit of a tangent here, but where there are known constraints and we are looking to develop in that certain area, there's always a works program ahead of time. So we're on a particular site at the moment, we're trying to work with council to get a developers agreement in place to, I guess, not require that wastewater mitigation, because wastewater mitigation is really a bit of a band-aid approach as I see it. You're putting something in place because the infrastructure is under capacity, and it's required at that point in time, but the network at some stage in the future is going to be upgraded. And where it's known and there's a works program for that to be done, say in a couple of years' time, you don't want to burden, I guess, those future landowners, and not quite in perpetuity, but for, say 50 years until that site's redeveloped again. So we haven't explored the need to, explored pre-treating them. And I'd be keen to, I guess, know if anyone has done that. I know there's some areas in Auckland that have been, I think, kind of black zoned or red zoned, whatever you want to call it, where they've stopped development because there isn't capacity in their infrastructure, but we haven't quite got there yet in Wellington. So I'd be interested to know if anyone's had to navigate that in Auckland or any other council as well.
And another question, which is sort of in a similar vein to what you're just talking about, do you think the balance in private tanks and pumps versus the public upgrades is right? Do you think that balance is right at the moment?
I think it's heading in the right direction. We're obviously seeing a lot, councils gearing up through the Three Waters reform to be able to spend more on infrastructure and therefore kind of I guess sort out those problems that are there. At the moment, it's being put on the private developer to put in solutions to mitigate those problems at the moment. But where we do have larger developments, because my experience is largely in that multi-unit space, the small tanks, council doesn't want to take them in public ownership. But where you do get into that larger development, maybe greenfield or I think anything over probably 30 lots, our local council may consider starting to explore taking those shared wastewater tanks on as a public asset.
Have you, this is not a question from the chat, but a question from me. Have you had any occasions where you want to install those tanks in sort of council land or road or anything like that, or have they always had to be contained within the development site?
I have had one development, which was a 82 lot multi-unit development where we were able to use some of the road reserve to install a wastewater pump station. So yes, they were, but again, I guess it comes back to the scale of the development, and I guess for the developer justifying that cost to up spec the pump station from the requirements of a private pump station to a public pump station that can be vested. So there's quite a big, I guess, difference in the requirements for the pumps and the telemetry and all the gear that gets put in.
I think you've just answered my next part to that question, where it is in road or in council space that becomes a public asset, does it, rather than private?
Correct. Yeah, it got vested to council. Yeah.
Yeah, cool. Okay, another question from the chat. Great presentation, well done. In your experience, how do you find Wellington Water's flood mapping when compared to on-site? I recently heard that an update in Kapiti's flood mapping put several properties in a much better position, i.e. less flood risk than originally thought.
Yeah, interesting. Yeah, there's always, I guess, a degree of ground truthing that needs to be done. And for example, one of our engineers lives in the Hutt Valley. She's had her house in a flood mapped area. The flood mapping got updated and suddenly it wasn't as well. So it kind of, benefited her in that case. But you see other examples of, I guess, flow paths being shown through certain areas, which I guess would surprise you from being on the ground. But they do it to LiDAR, and I'm conscious of my audience here, but there's a, certain inaccuracy in using LiDAR for versus just doing, basing it off a topographical survey. And when we do think there are large, I guess, discrepancies from what the modelling is showing and what we see on site, we can get the flood modelers to incorporate our topographical survey data into it and basically rerun a base pre-development scenario, which can help in some instances.
Or another question here, any thoughts of, about the increasing volume of jointly owned access legs and whether this will cause maintenance issues in the future or make it better? Do you think new buyers fully understand their responsibilities in this regard?
You'd hope that new buyers understand their responsibilities if they've been informed by their solicitor correctly, but increasing volume of Joels, I think, yeah, I think not so much just Joels, but also residents associations. There was people have been, I guess, burnt by body corps, and so residents associations seems to be the new way of navigating that. But we're seeing, or our developers and our clients are seeing people, again, because of this increase in choice in the market, where there's a residents association involved, then buyers, may be able to go down the road and buy a standalone house without those ongoing shared assets and obligations. I have a house on a shared driveway myself, which is probably 30, 40 years old, and that will need redoing at some stage. But I guess I understood that because I'm in the industry and understood my rights to do that. So I guess it kind of comes down to, yeah, if they are informed. But the bigger problem is probably the shared wastewater tanks, because there's not only does that need replacing at some stage, but there's an ongoing maintenance and, blockages, I guess, and issues that need to be regularly addressed.
Cool.
Hope that answers the question.
Yeah, no, that's good. I can turn and look and see if the asker of that question is answered. That looks like it's all from the chat. Has anyone got any questions from the floor? Feel free to turn your microphone on and ask.
Stunned silence.
Yep. I think no, that sounds like it's it. So thanks very much, Sam. That's been really awesome.
No
Very
worries. Thanks for having
informative
me.
presentation and much appreciated. You giving of your time for us. It's been great. So that's it for our two presentations in this little bit, where Cadastral Stream is going to look at collaborating with the position and measurement stream to deliver a survey measurement themed webinar later in the year. It'll probably be GNSS focused, so keep an eye out for that. That's another competency for our licensing. So we will look to try and get something out there later in the year. But thank you again, Sam, and thank you everyone for turning up. If you missed our planning one 2 days ago, I think both of these presentations are going to be, they've been recorded, and hopefully they'll be made available on the website. Thank you, everyone, and we'll catch you next time.
Thanks, Carl.
Cheers, Sam.